welcome. Let's do some advanced problem solving with trig ratios. So we're just using our trig ratios to do a little investigation to solve some problems. We're still not solving for missing measures, right? We've got all of our measures there, but we're learning some things about the different trig ratios. All right, so let's first of all work with angle S. All right, so angle S here is going to be our reference angle, right? Across the triangle would be the opposite side. Making up part of that angle S is the adjacent side. And then, of course, opposite the right angle is the hypotenuse. And by the way, this is in your notes, so you can fill in the chart with me and answer the questions with me. All right, so now that we've got our triangle labeled from angle S's point of view, let's find the sine ratio, the cosine ratio, and the tangent ratio for angle S. Right? So number sine, actually I'm going to write them all up here. You don't have to write the ratios. You've got these in your book. I don't have them on this page, so it's always good to review. So sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse, and tangent theta is opposite over adjacent. Okay. All right, so sine S is going to be 5 over the square root of 61. And now we want to rationalize, so we're going to multiply by the square root of 61 over the square root of 61. In the numerator, we'll have 5 square roots of 61. And in the denominator, square root of 61 times the square root of 61, that is just going to be 61, right? Because the square and square root will cancel. I'm going to switch colors each time, just so that, because these kind of, I took up every bit of that box, and so you have enough room to see. I'll switch colors. It makes it a little easier to tell one problem from the next. All right, so cosine S. All right, so the adjacent side is 6, and cosine is adjacent over hypotenuse. The hypotenuse, of course, is the opposite the right angle, so square root of 61. We'll have to rationalize this one as well by multiplying by the square root of 61 over the square root of 61. That would give us 6 square roots of 61 over 61. And now let's do the tangent ratio. Tangent is opposite over adjacent. This one is nice and easy. It's just 5, 6. Right? So I'm not going to write sine S equals and cosine S, because we have a chart here. We have a table. We'll just write the ratios in. All right, so now let's try for angle T. The one thing that's going to change, oops, well, I guess these things were kind of connected. There. Now I think they won't be connected. No, they'll still be connected. All right, so if angle T is now our reference angle, our angle of interest, all right, the opposite now is across from the triangle. It's the other side. It's T, or it's 6. And the adjacent side makes up part of angle T. That's 5. And of course, opposite the right angle is the hypotenuse. All right, so now let's find the trig ratios here. All right, so sine is now going to be, so opposite is now 6. So it'll be 6 square roots of 61. 6 over square, let me try that again. 6 over the square root of 61. And again, we'll rationalize. I'll write it out, but I think you might recognize the answer is going to be 6 square roots of 61 over 61, because I think we've seen that somewhere before. Cosine is adjacent over hypotenuse, so now that will be 5 over the square root of 61, and again we'll rationalize. So that's just going to be 5 square roots of 61 over 61. The tangent ratio is opposite over adjacent, so now it is 6/5. So you might see some relationships between the different trig values. So if you notice, some trig values are equal to one another. If we look at sine s and cosine t, they were the same value. So both sine s and cosine t equal 5 square roots of 61 over 61. They were the same. And that makes sense because opposite and adjacent switch depending on the angle. So what was opposite is now adjacent. What was adjacent is now opposite. All right? So the sine of one is equal to the cosine of the other angle. And likewise, both sine t and cosine s equal 6 square roots of 61 over 61. They're both equal as well. All right? So your sine value for one angle will always equal the cosine for the other angle, and vice versa. How about how are tangent s and tangent t related? Well, notice what's opposite and what's adjacent switches. They are reciprocals of one another. So tan s and tan t are reciprocals of one another. And underneath, let's just add the fact that opposite, we can abbreviate, and adjacent sides switch. When we switch angles. And oops, we're missing a C there. And I'll abbreviate angles as well. All right, so that would make sense that those would be reciprocals of one another. All right, so if you need me to pause, I'll pause the tape when we're watching it. Otherwise, let's go to the next problem. We only have a few problems here. They're a little more involved, but there's only a few. I want to say three. I think there's 3 problems, and then a couple things to go over. All right, so if theta is an acute angle of a right triangle, and sine theta equals 4/7, what is tan theta? Now, I want you to, this is in your notes, and I've written all the steps here. This is a homework problem, so you will want to write the steps. I don't have the book in front of me, because I gave my last one away. And so I may have the steps written in the notes, but I'm not 100% sure. So if I don't have the steps written in the notes, then you'll want to write them in your notes. All right, so step 1 is to draw a right triangle. It doesn't matter what the right triangle looks like. You're just using it as a model to put the sides on. All right, so it's just there to organize your information. Label one angle with a variable, not the right angle. All right, I'm going to label this angle. There's my triangle. I drew a triangle. You draw a triangle too. And I'm going to label one of the angles. It has to be one of the acute angles. Right? So it's never the right, because we never start with the right angle. We're going to determine the known sides from the given ratio. And in your notes, I want you to add that a trig ratio is simply 2 sides of a right triangle. Right? Back here, when we were finding the trig ratio, the tangent ratio for angle T, right? We just took 6 over 5. 6 is the opposite side, 5 is the adjacent side. Right? So if you're dealing with sine, the numerator is the opposite side. The denominator is the hypotenuse side. Is the hypotenuse. If you're dealing with cosine, the numerator is the adjacent side. The denominator is the hypotenuse. And if you're dealing with tangent, the numerator is the opposite side and the denominator is the adjacent side. But be careful, if there was a radical in the denominator, it might be rationalized. All right, and I'll show you how to figure out what to do if it's been rationalized. So really, it's just So notice how we multiplied by a square root of 61 over the square root of 61. Before we did that, there was no square root of 61 in the numerator. So if you saw 5 square roots of 61 over 61, your numerator would just be 5. So the opposite side is 5. Your denominator would be the square root of 61, not 61. It became 61 when we multiplied by the square root of 61. All right, so that's how you can figure it out if it's been rationalized. And if it's been reduced, well, it's fine, because your answer would be reduced anyway. So you're not going to have to worry about it being reduced. It's just if it's been rationalized. All right, so we want to determine the known sides from the given trig ratio. We are given, so we've got our triangle, we labeled an angle, we're given sine theta equals 4/7. We know that sine is opposite over hypotenuse, as I just went over on the last slide. That means that 4 must be the opposite side and 7 must be the hypotenuse. Right? So chances are I'm not going to give you one that's been rationalized or reduced. I'm going to give you nice pretty numbers. Now you might have a radical in when you're solving for the missing side, but usually I'll give you nice pretty numbers like that. So opposite the given angle is going to be 4. That's the opposite side, right? Because it's all relative to our angle, and that's going to be our angle of reference. The hypotenuse is always opposite the right angle, so that's going to be 7. We have a missing side. We're just going to use Pythagorean theorem to find our missing side. And I'll label our triangle here because we know 4 is the opposite and 7 is the hypotenuse because we're given the sine ratio. All right, so to find our missing side, we're missing a leg. So 4 squared plus x squared equals 7 squared. 4 squared is 16. 7 squared is 49. We'll subtract 16 from both sides. X squared is equal to, if we subtract 16, that would be 33. And so x is going to equal the square root of 33. Now, although 33 is not a prime number, its two factors are 3 and 11. They're prime and they don't match. So that's as simple as it gets. So that means that our adjacent side is the square root of 33. So now we can find the trig ratio we're asked for. All right, so the trig ratio we're asked for is what's tangent. So tangent theta is going to be opposite over adjacent. We were given the opposite side, that's 4. The adjacent side is the square root of 33. If you look up above there in these answer choices, notice that none of them say 4 over the square root of 33, and that's because this one's been rationalized. So I'll be nice. The only one I'll have you rationalize is the one at the end. I won't give you one that's already rationalized and make you work that hard. So if we multiply the numerator and denominator by the square root of 33, we find out that the tangent ratio is 4 square roots of 33 over 33. All right? And you have the whole problem in your notes, so make sure you add all of it. So if you're given a trig ratio, you're given 2 sides of a right triangle. Now possibly reduced, but you're given 2 sides of a right triangle, and you can find the third side using Pythagorean theorem. And then you can find any trig ratio anybody wants. Okay? If you have any questions on this, I can do more examples in class. Just ask. Okay? And this is the only one I'm going to do in class. I'm going to do on the video. All right, so we're going to do something similar, though. We're going to label the triangles. We've got a table of values here, and they are not in simplest radical form. So now this I might do. If I'm going to have a radical, I'm not going to rationalize it. If I'm going to give it to you to be able to figure out sides of a triangle, right? Because if I reduce it and I rationalize it, I'm going to make it too difficult for you. But here, these have not been reduced and they've not been rationalized so that we could easily figure out the sides of our triangle. So remember, sine is opposite over hypotenuse. Right? And so we have opposite and hypotenuse for this one, opposite and hypotenuse for this one. Cosine is adjacent over hypotenuse. And I guess I should write it like that. It looks a little clearer. And tangent is opposite over adjacent. All right, so now let's work with A first. All right, and then we're going to check with B. So if you were asked to label a triangle, you essentially have your sides. You can use one to fill in the sides. So we'll fill in the sides using angle A, and we'll check using angle B, because they both need to work out. All right, so using angle A, opposite angle A, so this would be the opposite side for angle A. This would be the adjacent side. And if, whoops, ignore that. I got part of this blocked. This would be the adjacent side. And I hope everyone thought, actually I'm just going to put A, D, J. Everyone thought, whoops, that can't be the adjacent side because this is the hypotenuse. All right, so we've got opposite and adjacent and hypotenuse labeled. All right, we want to label that because that's going to tell us where our sides go. Because our trig ratios give us the opposite side, the adjacent side, and the hypotenuse relative to an angle. So from A's point of view, the opposite side is 4. All right, so I'm going to just replace this with a 4. All right. The adjacent side, and I actually will do the hypotenuse next. The sign also gives us the hypotenuse. In the denominator of our sine ratio, we see 2 square roots of 10. Actually, let me write in the same color. I'll write these in blue as we're changing them. Cosine is adjacent over hypotenuse. All right, so let's replace that adjacent side. All right, so opposite over adjacent. That means the adjacent side in the denominator for tangent must be 2 square roots of 6. Now, let's check and see if that works with cosine, because we kind of, we only did part of cosine. Let's check cosine out. Now, cosine is adjacent over hypotenuse. All right, so this is the adjacent side for angle A, and of course, that's the hypotenuse. That checks out. Let's use angle B and check with angle B. Now, from angle B's perspective, this is opposite. This one is adjacent. And this is still the hypotenuse. All right, let's check the ratios. All right, so for angle B, the opposite should be 2 square roots of 6. Yep. Hypotenuse, 2 square roots of 10. That worked out. Let's check cosine. The adjacent is 4. Yes. Hypotenuse, 2 square roots of 10. Yes. And then for tangent, the opposite is 2 square roots of 6, and the adjacent is 4. So notice that when we check with angle B, our sides match what we got when we did it with angle A. What's opposite and what's adjacent switched, but not what the side values are. So here we can use trig ratios to label the sides of a triangle. Right? And so now we have correctly labeled our sides in the triangle. And the angles have already been labeled, so there's nothing to do there. All right, so I just want to sum up our lessons. All right, so the side opposite angle A is side A, little a. The hypotenuse in this example here is opposite the opposite angle C. It's always opposite the right angle. You have this, by the way, in your notes. I think it's all filled in, but if it's not, just add to it. Hypotenuse is always opposite the right angle. And so in this case, since our right angle is angle C, our hypotenuse is side C. And notice it's a little c. And the side adjacent, or next to angle A, is angle B, and that's opposite of angle B is side B. It's adjacent to angle A. We use a little b. All right? So for our triangle here, since our angle of reference is going to be angle A, side A is the opposite, side B is the adjacent, and side C is always the hypotenuse because it's opposite the right angle. So now I'm going to give you a little handy device to help you remember the trig ratios, and that is SOHCAHTOA. So say it with me, SOHCAHTOA. I'm going to make you say it in class too. SOHCAHTOA. So, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. I bet you can find a random adult and say SOHCAHTOA, and they probably know what it means because they learn to memorize it the same way. And when you memorize it with a little mnemonic device, it makes it stick in your brain so it never ever leaves. All right, so final reminder using, second to final reminder, using our triangle here, sine A. So it would be the side opposite angle A over the hypotenuse. It'd be A over C using our triangle that we see right here. Cosine A is the side adjacent to angle A over the hypotenuse. So in our example here, it'll be B over C. And tangent is the side opposite angle A over the side adjacent to angle A. So for our example here, it would be A over B. All right? And let's do one last little fill-in together to help you remember some things that you've learned so far about trig ratios. So a right angled triangle contains one angle of 90 degrees. And actually, if I'm doing this live, I may pause the tape and have you tell me what goes in the answers. In a right triangle, the longest side is opposite the blank angle and is called the blank. Well, I hope you know the first one is opposite the right angle. The longest side is opposite the largest angle, and that would be the right angle, and it's called the hypotenuse. The other two sides are named in relation to the angle you are working with. The side opposite this angle is called the, and I hope you figured out, it's the opposite side. The side next to this angle is called the adjacent side. That's what adjacent means, next to. You must identify these sides correctly when solving problems using trigonometry. The tangent, cosine, and sine ratios are constant for any given angle. Remember the formulas. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. So next, we're going to be solving so many different problems using trig ratios, you will just be amazed. Thanks for watching. Bye for now.